Welcome to One Chemistry. This is 365 Chemistry series. Daily one question for you. Here four different heterocyclic compounds are given. You have to arrange these compounds by its basicity. P1 is imidazole architecture. Q1 is 5-member and 6-member ring with nitrogens are in conjugation. R is with 3 nitrogen in conjugation. And S is a just pyridine. You have to arrange these four based on its availability of lone pair and hence basicity. Here basicity is decided by lone pair donating ability of nitrogen. So easy the donation, good will be the basicity. Here basicity dictated by electronegativity. Electronegativity of hybridization. Electronegativity of hybridization in the order of sp, sp2, sp3 because of more s character. So more the electronegativity, less electron donating ability, less basicity. Here let us analyze what are all the hybridization inside. If you look at the P, it has one sp3 and one sp2 carbon. The problem is sp3 electron involved in conjugation create the aromaticity. Then Q, one sp3 and one sp2, 2 sp3 and 1 sp2, then S, 1 sp2 nitrogen. So if you look at it, more acidity mean more sp2 nitrogen, which is R, then comes Q, then P, finally S. Here the concept you have to learn here is lone pair donating ability decided by hybridization. In hybridization, sp is more electronegative, then sp2, then sp3. That's all from this video. Thanks for watching.